So solve it using definition of Laplace transform. Definition of Laplace transform is integral 0 to infinity exponent negative st ft dt. So however, ft here you have two different value at two different interval. That's why you integrate for 0 to 3 exponent negative st. The interval t 0 to 3 ft is actually 2. So 2 dt. And then t greater than equal to 3. So we integrate from 3 to positive infinity exponent negative st. So multiply with the ft is t squared minus 3t plus 1 dt. So the first integral 2, you can factor out 2 and then integrate exponent negative st where the s is a parameter like a constant value. So you get exponent negative st divided by negative s. And then t from 0 to 3. Second one, you have the product form. So you need to use, we prefer to use a tabular method. So maybe we can do, you can do somewhere on another piece of paper for your tabular method or at the bottom. So we have that tabular method. If you have the product form with polynomial, always choose u as polynomial. Always choose u as polynomial. So you have the sign and then the u, you got the dv. Sign start from positive. If you got a polynomial, then choose polynomial as u, which is t squared minus 3t plus 1. So you got t squared minus 3t plus 1. dv is exponent negative st. For u, you differentiate, if polynomial, then the u you differentiate until you can get 0. So sign alternate, start from positive and then negative. So this is actually u you differentiate, so you get this is a du. So 2t minus 3. This is a dv you integrate in order to get v. So this is negative 1 over s exponent negative st. And then you alternate plus. So differentiate 2t minus 3, you got 2. So integrate again negative 1 over s exponent negative st, you have positive 1 over s squared exponent negative st. Then, so differentiate to 0, and then you can stop at this row if the u is polynomial. So here you get negative 1 over s cubed exponent negative st. The result follow the slanting row. Because remember you have this is actually a systematical way for of your by part integral by part. U dv, the result you have uv minus integral v du. So this is u. Integrate dv, you get v here. That's why this is uv. So this is uv, uv, several times of integral by part. And this part is actually the horizontal row. And here is actually because you got integrate your, this is v, this is du. So integrate 0. That's why this part 0. So if you got product form which is not from polynomial, let's say you got sin exponent or sin cos, then the horizontal row is actually this part, the integral v minus integral v du. So but you already take care the sign here. Hence, the slanting row is actually the result of u times v. So you have positive times negative 1 over s exponent negative st. Second result, you have negative 2t minus 3 divide s squared and then exponent negative st. The third result, you have negative 2 over s cubed exponent negative st. Okay, so you put out the result for here. Okay, you put the result into here, and then limit for your integral is from positive 3 to infinity. So to copy it, not difficult. T squared. Okay, and I will prefer to, okay, its result is multiplied by exponent negative st with a factor, okay, here negative 1 over s. So I will factor out negative 1 over s exponent negative st. So yeah, negative 1 over s exponent negative st. So we have factor out this term. So multiply with t squared minus 3t plus 1. T squared minus 3t plus 1. For the first case, slanting arrow there. Okay, the second result, okay, negative. I already factor out negative 1 over s exponent negative st. So left 2t minus 3 divided by s. So it's negative, or factor out negative, so this will be positive 2t minus 3 divided by s. Okay, or you want to bring the s, okay, you don't want to factor out, okay, 1 over s, so this is divided by s, this term is divided by s squared. Okay, and the last term, you have negative 2 over s cubed. I already factor out negative 1 over s, so we're left negative 2 over s squared. So negative 2 over s squared. Okay, put in the limit from 3 to infinity. So exponent negative 3s. Okay, when you plug in 0, this is minus 1. Okay, exponent 0 is 1. Okay, and then, okay, when we plug in, first of all, for the second integral here, when you plug in infinity, remember exponent negative s infinity is 0. So the first term I got plus, mean the upper limit I got, okay, the result should be 0. It will be 0 because exponent negative s infinity is 0. So 0 times anything here, you got 0. Okay, and the second term is when you, okay, minus with lower limit, so minus with, okay, negative 1 over s, we come get positive 1 over s, because minus with negative 1 over s, then t is 3, so exponent negative 3s. So plug in t is 3, so 3 squared 9. Plug in t is 3, so minus 9, then plus 1. Plug in 3, t is 3, so 6 minus 3, you got 3 over s, so minus 2 over s squared. Okay, then you can simplify it. We'll write a bit here. So mention out this one, become 1 minus exponent negative 3s. Okay, or expand. Let me expand it. So 2 over s minus minus 2 over s exponent negative 3s. Okay, here 9 minus 9, so you get 1 over s, so you can add up 1 over s exponent negative 3s. So this is 3 over, okay, total is 3 over s squared. Okay, this term is minus 2 over s cubed exponent negative 3s. Yeah, so a bit messy. So if can, this one you can write okay, another piece of paper. So I try to, so this two term you simplify, so it should, 2 over s. This is, okay, negative 2 over s, exponent negative 3s plus 1 over s, exponent negative 3s. Okay, or I collect, okay, together all the exponent negative 3s. So total is s cubed. So exponent negative 3s over s cubed. So this term is, okay, from here, s cubed, this term you got minus 2. Okay, and then if you over s cubed, this is s squared, so you have to multiply s here, multiply s. So this will be plus 3s. Okay, this one is negative 2 over s plus 1 over s. So you got negative 1 over s. Okay, negative 1 over s. Okay, you want to make up become s cubed, you multiply by s squared. So negative s squared. Let me check. There's a mistake there. And okay, sorry, this is positive. Okay, here negative 2 over s cubed, but I factor out negative. So I factor out negative, so this one is positive. This is positive. So the answer is 2 over s plus exponent negative 3s over s cubed. Okay, bracket 2 plus 3s minus s squared. This is using the definition of Laplace transform. And you got the and expand first, t minus 3, t minus, what is that? T minus 5. T minus 5 power 3. You can expand it. This will be t power 3. So this is minus, so positive, negative. So if power 3, this is using the binomial expansion. Okay, or you may expand, okay, or you may multiply t minus 5 3 times. So this is, we have 3 t squared, and then have 5 power 2 plus 3t 5 cube. Okay, and then sorry, 5, this is 1. Okay, sorry, t cube and then t squared, this one t power 1, 5. Okay, from initially, if this is 1, you will multiply this 5 power negative 5 power 0, this is negative 5 power 1, that's why negative 5. This is negative 5 power 2. Lastly is, okay, or I do it slowly. Lastly, we have negative 5 cube and t cube minus 15t squared plus 75t, okay, minus, okay, 125. Then the Laplace transform for t minus 5 cube will be the Laplace transform for t cube minus 15t squared plus 75t, okay, and then minus 125. So it's a Laplace transform for t cube, okay, add up with your Laplace transform for negative 15t squared plus Laplace transform for 75t plus Laplace transform for negative 1 to 5. So this is so-called the linearity property. Mean you have the addition or subtraction, you can break the Laplace symbol there. Then now Laplace transform for t cube. Okay, as you know, the Laplace transform for t power n will be n factorial divided by s n plus 1. So t cube will be 3 factorial divided by s power 3 plus 1. So negative 15 constant, you can factor out negative 15 and then Laplace transform for t squared. So similar with Laplace transform for 75t, you can factor out the 75 and then find the Laplace transform for t. And then this is a Laplace transform for a constant. Okay, as you learn the first formula for Laplace transform for a, you have a over s. So this will be negative 125 over s. So you have 6 over s to the power of 4. Laplace transform for t squared, you have 2 factorial divided by s to the power of 2 plus 1. So Laplace transform for t is 1, 1 factorial divided by t power 1. So 1 plus 1 minus 1 to 5 over s. So it's 6 over s power 4 minus 2 factorial is 2. So 30 over s cubed plus 75 over s squared minus 1 to 5 over s. Check question A. 6 over s power 4 minus 30 over s cubed plus 75 over s squared minus 125 over s. This is so-called the linearity property. Mean t cubed is either you expand using this is a binomial expansion, or you may do it 3 times. This one, if this is negative, is normally positive, negative, positive, negative. Start from t power 3. The last one is actually negative 5 power 3. We have negative. Positive, negative, positive, negative. If this is plus, all will be positive. And then how I do it? T cubed. Later on, t index will be decreased. T squared. And then the coefficient here, if power 3 using what the expansion, this will be 3. This is 3. Like you have a plus b squared, you should have a squared. So 2, middle you have 2, and then 2ab plus b squared. Because from a squared, a reduced, a power 1, and then b power 1, later on b squared. The power of b increase. So same thing here, t cubed, t squared, and then t power 1, and then 5 here, 5 power 1, 5 power 2, 5 power 3. Because it's negative, that's why you have positive, negative, positive, negative, or you expand it slowly. Then you apply the linearity properties of Laplace transform. The first shift property. First shift property. Laplace transform for exponent a t f t, the result is fs minus a. Hence, you have to from the question exercise 4b, question 1l, Laplace transform for t squared exponent negative 4t. So you compare with first shift property, where in this case your a is actually what is the a value? Shafika, are you around?
Yes, doctor.
Compare t squared exponent negative 4t with the first shift property formula, which is Laplace transform for exponent a t f t. The result is fs minus a. So can you tell me what is the a value? What is a? What is a? You just observe the formula and the question. Compare. What is the a value? What is your a value and what is your ft? What is the a value? If you cannot compare, then and don't do this one as Laplace transform for t squared multiply Laplace transform for exponent negative ft. This is wrong. You just compare this one. Compare the exponential term with exponent negative 4t and tell me what is the a value. What's the a value? Compare exponent at with exponent negative 4t. What is the a value here? Shafika,
I'm not sure, doctor.
can you can compare, right? You compare your orange and orange. Compare exponent and exponent. Compare exactly. This is e, this is e, this is 80, this is negative 40. So what is the a?
-4.
Yes, compare like this. And then call the next one. No Sahidato.
Yes, okay.
Compare the first shift property with the questions here. Exponent 80 you compare with exponent negative 40, so a is negative 4. And then tell me, compare ft with t squared. So tell me what is your ft here.
T squared.
Yes, thank you. So mean you can solve this question using first shift property, where the result they tell you is fs minus a. We should have the formula. If we add the module or later on, then we can extract out. In the final online, we won't give you the formula, so you can print out the formula by yourself. This is so-called the table of Laplace transform. We have shown Laplace transform for a is a over s, exponent at is 1 over s minus a. Sin at you have a over s squared plus a squared. Cos at is s over s squared plus a squared. Hyperbolic sin at is a over s squared minus a squared. Hyperbolic cos at s over s squared minus a squared. Laplace transform for t power n is n factorial over s to the power of n plus 1. Laplace transform for exponent at ft. The result is fs minus a. To read the table, so this is on top, this is a definition of Laplace transform. Laplace transform for ft is actually equal to the integral of ft exponent negative st dt. Integrate from 0 to infinity. The result is function of s. So given ft, the Laplace transform is fs. So this is a ft. This is the result of your Laplace transform. And then we still have other functions that we are going to look through later. So up to now, we have here, you got the 7 basic formula. A, this is 1, 2, 3, 4, 5, 6, 7. T power n. And then linearity property is not mentioned here. And this is the second property, which is first shift property, Laplace transform for exponent at ft. The result is fs minus a. So you can highlight this formula. Later on we are moving to the Laplace transform for t power n ft. The result is negative 1 to the power n. dn ds n fs. And then you have here Laplace transform for yt is ys, first derivative. So s ys minus y0, second derivative s squared ys minus sy0 minus y prime 0. We use this one. Then later on, after you learn Laplace transform, we are going to so we transform everything in terms of s, and then to get back the result which is in terms of t, we need to inverse it back. So we have the Laplace transform, we got inverse Laplace transform. And then the special case of the Laplace transform, you can solve where the ft is non-continuous function compared to the technique that we learned in chapter 1, chapter 2, and chapter 3. All the ft are continuous. Okay, and then hence the result is fs minus a, where the a is negative 4. Before you can get fs minus a, you must get fs. So what is a fs? Fs is the Laplace transform for your ft. Okay, and then your ft is t squared. That means the fs is actually the Laplace transform for t squared. So use back the first 7 formula, t squared t power n. So it's 2 factorial divided by s to the power of 2 plus 1, which is s cubed. So you got 2 over s cubed. Okay, and then so you have the fs a is 4. So minus negative 4 become fs plus 4. So s replaced by s plus 4. So make sure you bracket it. So the answer for Laplace transform for this one, right? The result is actually fs minus negative 4. Okay, where the result 2 over s plus 4 cubed. So this is so-called the first shift property. Okay, let's see. So any questions here? This one for first shift property. First shift property, you have the product form where one of the function must be exponent at. Exponent at. And let's see if still got any more question that can be done. 4b, 4b. Okay, then we convert the sinh this is where the a is 1. Convert the this one to sinh 1t will be x. Okay, you have half, we factor out. So it's exponent t minus exponent negative t. Okay, then Laplace transform for t over 2 exponent t minus exponent negative t. So in this case, you can apply linearity property first, where is a Laplace transform for t over 2 exponent t, minus with Laplace transform for t over 2 exponent negative t. Okay, and then you can factor out half. Then you have Laplace transform for t exponent t. So minus half Laplace transform for t exponent negative t. So in this case, you have, if you apply the first shift property, which tell you the Laplace transform for exponent atft. The result is fs minus a. Fs minus a. So I got here exponent t, this exponent negative t. So we look at the first k term first. Laplace transform for t exponent t. T exponent t. Then what else? Muhammad Haris. Muhammad Haris, are you around? Muhammad Haris.
Yeah, Doctor.
Okay, compare the Laplace transform for t exponent t with the first shift property. So what is the A? And what is your ft? Look at the first term, Laplace transform of t exponent t compared with the first shift property, exponent at. So what is the A value here?
A value is 1.
Yeah, A is 1. Ft, this one, A is 1. Your ft, where's the ft? Where's the function of t? Compare exactly. You have exponent 1t, ft. So where's the ft here?
1.
1. Then you got t. Why 1? T exponent t compare exponent at ft. So ft is t lah. Why 1?
Oh, okay. Sorry, Doctor.
So if you look this one, Muhammad Firdaus. Muhammad Firdaus, the second term. What is the A?
Yeah, yes, Doctor.
What is the A for the second term? Compare T
Ne- ne-
A.
-1.
Okay,
A dia
correct.
-1.
Okay, FT.
Negative T.
Never mind. Negative we put outside, so we take T. Negative right out, factor out. So this is T. Okay, and then using the first shift property, the result, okay, will be this one. The result will be half f s minus 1. Okay, so the second term half f s minus negative 1. Because Laplace transform exponent at ft, the result fs minus a. So a for the first term is 1, so fs minus 1. Second term, a is negative 1, so fs minus negative 1, which is s plus 1 lah. Okay, so you got half fs minus 1, this minus half fs plus 1. Okay, both okay, you got the same f, this is same ft. Okay, so okay, given ft is t, the fs is actually the Laplace transform for your ft. Okay, or the Laplace transform for t. Okay, who else to call? Hadira. Hadira? Hadira, are you around? Hadira? Hadira, are you around? Hadira. Okay, we call the next one Farhan. Farhan,
Yes, Doctor.
what is the Laplace transform for t?
T one over
1 over s what?
S power of
Power of what? 1 plus 1 lah, 2.
1 plus 1 2.
Okay, fs is 1 over s squared, because ft, both ft same. So both fs is 1 over s squared. So fs minus 1. Okay, you can factor out half. So mean s replaced by s minus 1. So the second term s replaced by s plus 1. and then you may simplify it. Okay, cross multiplications. S plus 1 minus S minus 1. Okay, divided by, okay, you got S minus 1, S plus 1. So S plus 1 minus S, okay, no more S. So 1 minus negative 1 is 2. So 2 over, okay, this will be S squared minus 1. So your answer is 1 over S squared minus 1. Is it correct? Okay, check. Just now is what? T sin T. Q. Not correct. Where's a mistake? 2S over S squared minus 1 squared. Let me see where is the miss. This one using the another property but should get the same answer. Am I? 2S over S squared minus 1 squared. Is it correct? T sin T. Okay, let me check. Okay, any mistake? Sin T exponent T minus exponent negative T divided by 2. Okay, so 1 over S squared. So I just replace 1 over, okay, I didn't square it. Yeah. Fs is 1 over S squared. So Fs minus 1. S here replaced by S minus 1 and then you squared it. So this is Fs plus 1. So 1 over S plus 1 squared. Okay, and then so this will be S plus 1 squared minus S minus 1 squared. Minus 1 squared. Okay. So this is 1 over S minus 1 squared. So I will have the cross multiplication S plus 1 squared minus S minus 1 squared, okay, divided by S minus 1 squared times S plus 1 squared. Okay, you may expand the numerator. So S squared plus 2S plus 1. So minus S squared minus 2S plus 1. Okay, I don't want to expand this one. S minus 1 squared S plus 1 squared. Okay, and then you have S squared minus S squared cancel. 2S minus negative 2S. So total you got 4S. 1. Okay, 1 minus 1. Okay, so you got 4S. Numerator 4S, and then divide by the denominator. I didn't expand it. I should get S minus 1 squared S plus 1 squared. So my answer, okay, I should have S over S minus 1 squared S plus 1 squared. Okay, Q. S squared minus 1. Okay. What's this? hold on, we are going to check using the mapper. So the answer, okay, this is the answer given by mapper, okay. The Laplace transform for t sin t, you get the answer, okay, is 2s over s squared minus 1 power 2. 2s over s squared minus 1 power 2. We expand it, okay, we have 2s over s power 4 minus 2s squared plus 1. Okay, and then this one, I solve it, okay, using the first shift property by expand the hyperbolic sinh to exponent t minus exponent negative t. And then if I didn't expand it, I will leave the answer 2s over s minus 1 squared, okay, multiply s plus 1 squared, okay. So if we expand the answer, okay, from the solving using the linearity property, which, okay, we get actually the same, okay, the same the same answer. Okay, and later on we are going to show, okay, beside, okay, if we expand the hyperbolic sinh using the exponent at minus exponent negative at over 2, then we can solve using first shift property. Then you have two terms. Okay, and we got another formula which is multiplying by Tn, okay, formula. And the last formula, where is it already? Here. Okay, the Laplace transform for Tn ft, its result is negative 1 power n dn dsn fs. Okay, hopefully later on we use this, okay, formula, okay, we will get at hopefully should be the same form with this one. Okay, and then with Laplace transform for t hyperbolic sin t using first shift property. First shift property here by changing sin t to half of exponent t minus exponent negative t. Okay, now, okay, we can use the multiplying by Tn property, which state that Laplace transform for Tn ft, the result is negative 1 power n dn dsn fs. Fs is actually Laplace transform for ft. So here t power 1, so mean negative 1 power 1, which is negative. Okay, negative, okay, n is 1, so that's why it's negative dds fs. So t power 1, you got, okay, plug in n is 1, so you got negative 1 ds fs. Okay, fs is actually, what's the fs? Okay, fs is the Laplace transform for your ft. So you have to, okay, again, so you have to check the formula. I mean, compare the formula in this case. So if you compare the formula, n is actually 1. You compare with this formula, n is 1. Okay, this is the ft. Ft is hyperbolic sinh t. Okay, and then Laplace transform for hyperbolic sin t. Hyperbolic sin t. Okay, let's call someone. Hadira just now. Are you around? Hadira. Hadira.
And 80 minus exponent negative 80.
Okay, this is a sinh 80, okay, equivalence formula. Now, what I ask you, what is the Laplace transform for sinh 80? Okay, from the beginning of the first video. Now, what I ask you is not the, okay, another formula for sinh t. What's the Laplace transform for sin t? Do you, okay, okay, I don't know how do you all learn, okay, the lecture. Do you all print out the notes?
No.
Okay, if you don't print out the notes, okay, you download it in your phone or in your laptop.
In my phone.
In the phone, then open your notes lah. Open your notes, okay? Look at the formula. Fs is the Laplace transform. Since AT, result is here. A over S squared minus A squared. So now Laplace transform for sin 1t. What is the result?
1 over s square
Minus?
minus 1 square.
Yes. So that's why I said, okay, you have to get the quick answer, you have to memorize how to memorize, you have to do the exercise later on. So Laplace transform for sin t is, okay, 1 over s squared minus 1. Now, okay, the same question, just now we solve it using first shift property. First shift property, if we change the hyperbolic sin t to half of exponent t minus exponent negative t. Now we use the first multiplying by Tn property. We use this formula to solve it because we see, okay, you got, if you have a product of t with the ft, then you use this property. So t power n, you compare here, n is 1, so the formula is negative 1 power 1, so it's negative. So okay, n is 1, that's why it's dds fs. Okay, to get fs, you have to find Laplace transform for ft. Ft is a hyperbolic sin t. Okay, and then hyperbolic sin t is 1 over s squared minus 1. Okay, so now become the problem of, okay, the problem of differentiations. Okay, so now it's a problem of differentiations. So you want to dds, so in negative dds, okay, because the numerator is constant, easy, make it become s squared minus 1 power negative 1. So for differentiation, okay, you bring the power, already have negative, and then bring the power of the differentiation negative 1. Okay, and then for okay, differentiations, okay, s squared minus 1 power minus 1 will minus 2. Okay, you need to dds the bracket, which is s squared minus 1. Okay, so here negative, negative, positive. So you have s squared minus 1 power negative 2, which is s squared minus 1 power 2. dds s squared minus 1, you have 2s. So this is using multiplying by Tn property, we get the answer 2s over s squared minus 1. Yeah, that's what just now. 2s over s squared minus 1, s squared minus 1 squared. Okay, and if we use just now, if we change the, okay, sin term using the, okay, the exponential, okay, formula, half of exponent t minus exponent negative t. Okay, we arrive at here, and then if we expand both, okay, term, they are actually, okay, equivalent. Both answer are actually, okay, same, only different form. Unless you expand both, then you can see both are actually the same answer. Okay, so simplify, we have s squared minus 2s squared. You have, so minus s squared minus 1 divide s squared minus 1 squared. S squared minus 2s squared, so minus s squared, so minus 1. So differentiate one more time using the quotient, okay, form rule, which is vu prime minus uv prime divided by v squared. So in this case, second round, the u is, okay, negative s squared minus 1. The v, your v is s squared minus 1 squared. So your u prime is negative 2s, v prime is 2 times s squared minus 1, and then differentiate s squared minus 1, you have 2s. So total is 4s s squared minus 1. So the formula you said is a vu prime. So it's 4s s squared minus 1 v sorry, wrong formula. Yeah, vu prime here. vu prime, which is s squared minus 1 squared minus 2s, okay, minus uv prime, u, which is I can negative s squared minus 1, or factor out negative. Okay, u factor out negative, so negative, and then s squared minus 1 u v prime. V prime, you have 4s s squared minus 1. So divide by v squared. V is s squared minus 1 squared again. So s squared minus 1 power 4. And then simplify it. This one is s squared minus 1 squared. This is s squared minus 1, s squared minus 1. So total s squared minus 1, s squared minus 1, s squared minus 1 squared. So I got s squared minus 1 squared. And this term, this term, this term is the same term, factor out. Okay, hopefully got negative 2s. Negative, negative, this is plus. So plus 4s. Divide by s squared minus 1 power 4. So factor out 2. So 2s minus 4s. Okay, I'm not sure correct FK. So I obtain here this and this cancel, s squared minus 1 power 2. This one I factor out 2. So 4s minus 2s. Okay, let me check. Okay, using mapper, this is Laplace transform for t squared cos t. Not the same. They get is s plus 1. Where is the difference? So the mistake is here. That's why I factor out negative. So this one is s squared plus 1. So we have this is s squared minus 1. S squared minus 1 power 2. Then I just need to, I can only factor s squared minus 1. So first term, I still have the s squared minus 1 multiply negative 2s. This is positive. I factor s squared minus 1. I still have the s squared plus 1 multiply 4s. Delete. Okay, delete first. Okay, and then you have to expand, simplify. Hopefully we get the same answer. So divide by s squared minus 1 power 4. So this is power 1. So it become left power 3. And then okay, expand the numerator. So you have negative 2 s cube plus 2s. So plus negative 2s cubed plus 2s. Okay, this one plus 4s cubed plus 4s. Divide s squared minus 1 power 3. So 4s cubed minus 2s cubed, we got 2s cubed, 4s plus 2s plus 6s. Okay, divide s squared minus 1 power 3. Okay, factor out 2s. This is a s squared plus 3. Divide s squared minus 1 cube. Okay. Oh. So okay, just now, okay, up to here, differentiate one time. The result here, differentiate second time. This is the result when we expand. Okay, this one. This result. Okay, this is okay. Differentiation second time by mapper. This result. Where we expand it, we get. Let's now delete it. You got negative 6s multiply the s squared minus 1 plus 8s cubed divide s squared minus 1 power 3. So total we have here 2s, okay, 6 minus 6s cubed plus 8x cubed, 2s cubed minus 6s, minus 6s divide s squared minus 1 cube. So this is manually we do it using the multiplying by Tn property. We arrive at here 2s over 2s cubed plus 6s over s squared minus 1 cube. Okay, this one is the answer given by mapper. Directly Laplace transform for t squared cos t, you get this one. Okay, maybe you can prove by simplify this one. You can go back try to prove this one, whether this term equal to here. Mean you have to expand. I think I got to expand this s squared minus 1 cube and then this one, expand everything. Hopefully they are tally.